So chemistry, this time with the doubt solving sessions, our teachers and moderators are for you solving the chemistry doubts. Thank you for all the responses that you've given on the email as well as in the comment section down below. So this video is dedicated to all the most probable questions which come in the examination, the maximum interpreted questions, and the questions which mostly students have as doubts in chemistry. So this one's for you. Stay focused with your pen, paper, and start solving your doubts.
In solid AB having NaCl structure, A atoms occupies the corner of the cubic unit cell, and if all the face center atoms along one of the corners are removed, one of the axes are removed, then the resultant stoichiometric of that solid we have to find out. Now whenever we talk about the NaCl structure, which is one of the important things, students should understand what is the structure of NaCl. When we talk about NaCl, the ratio of Na and Cl is 1:1. So we are expecting the anions forms the FCC structure, and since the ratio is 1:1, the cations goes into the octahedral voids. So here the Cl minus is going to form the FCC structure. In this FCC structure, the Cl minus ions will occupy the corner as well as the face center position, while the octahedral voids of this, that is the edge center and the body center, will be occupied by the sodium. Now if I talk about here, they are saying A occupies a corner. That means now this is a position of A and this is a position of B. Now if I talk about all the face center along one of the axes are removed, if you put one axis and if all the face center, that means two face centers will be removed. So let us talk about first A atoms. A atoms corner as it is 8 into 1/8, but now face center out of 6 there are only 4, so 4 into half, so there will be 3, while B as it is 12 edge center multiplied by 1/4 plus 1 body center, so that will be 4. Therefore, the stoichiometric ratio is A3B4. Formula is A3B4. Our option is option D. The packing efficiency of two-dimensional square unit cell, we have to find out. Now this square is something like this. Now if you talk about this particular square, we have to find out the packing efficiency of this particular square. There is a circle, it's a two-dimensional thing. So whenever we talk about the packing efficiency, we talk about packing efficiency is nothing but the volume occupied divided by the total volume. But right now it's a two-dimensional, therefore we are going to talk about the area occupied divided by the total area. So this is something we are talking about area, not the volume, since it is a two-dimensional thing. Now this is a circle, as it is a two-dimensional thing. This is one circle and this is 1/4 part of a circle. So that makes around 2 circles over here. One circle is pi r square. So 2 circle its area occupied will be 2 pi r square. Now the total area, if I talk about, if I say the edge length is A, that will be A square. But this is kind of like a face center, FCC. A is equals to 2 root 2 r. So if I put it here, 2 root 2 r square, so it will be 8 r square. So now if I put it here, so this is 2 pi r square divided by 8 r square multiplied by 100. This will get cancelled. So this is 4. So 3.14. So 314 upon 4. So that is around 78.54%. Option D. Two solutions of glucose in water of concentration 0.01 molar and 0.1 molar are separated by the semipermeable membrane with respect to the water at 27 degrees Celsius. To prevent the osmosis, the solution on which the pressure is needed to apply and the magnitude of pressure respectively we have to talk. Now there are two solutions of glucose being separated by the semi-permeable membrane. Let us first talk about 0.01 molar. So if I talk about from this side, the pi 1 will be equals to CRT. So that is 0.01 multiplied by 0.0821 multiplied by temperature 300. So if you calculate this, you will get the answer 0.2463 atmosphere. Now this is, let's say, 0.1 molar side. So pi 2 will be equals to again CRT. This time it is 0.1 multiplied by 0.0821 multiplied by 300. So this is 2.463. So if I see this way, this particular solution is very dilute and this is concentrated. This has more pressure. So definitely there will be the flow from 0.01 molar to 0.1. So if we have to stop this particular flow, we have to apply the pressure on the side of 0.1 molar. And how much pressure is to be applied? The difference between the two. So 2.463 minus 0.2463, that is equals to 2.2167. So our answer is 0.1 and 2.2167. So our answer is option D. The difference between the boiling point and the freezing point of an aqueous solution containing sucrose, molecular weight 324, in 100 grams of water is 105 degree. If Kf and Kb of the water are given respectively, the weight of the sucrose in the solution we have to calculate. Now molality is nothing but the weight of the sucrose. I'm just assuming it as a X divided by its molecular weight 342. This is number of moles divided by its weight of the solvent, which is 100 grams given. It's gram, so I'm multiplying this by 1000. So this is around 0.0292x. If we talk about delta TF, that is equals to Kf into molality. Kf given is 1.86 multiplied by 0.0292x. If I calculate TF is nothing but 0 minus this particular data. So 0 minus 1.86 into 0.0292x. Similarly, delta TB is equals to Kb into molality. Kb given is 0.51 into 0.0292x. Now if I calculate TB is nothing but 100. That boiling point is always, solution is higher. So it is 100 plus this will be 0.51 into 0.0292x. But we have a data that TB minus TF is given to us, which is 105. So 105 is equals to, now we have a TB that is 100 plus 0.51 into 0.0292x minus this is 0 plus 1.86 into 0.0292x. When you will calculate this, we'll get 100. If we'll calculate this, we'll get 0.0692x. So 0.0692x is equals to 5. Therefore, x is equals to around 72.2 gram. So our answer is option D. At 25 degrees Celsius, the cell potential of the given electrochemical series 1.92 volt. The cell is given, the magnesium is with the Fe, this is cathode and this is anode and this is cathode. It's 2.37 for the anode given and the cathode is 2.45. We need to find the value of X, that is concentration of the Mg cell we have to calculate. We have a formula, first of all, E0 cell is equals to E cathode minus E anode. Now our cathode is Fe, so Fe given is it's minus 0.45 minus 2.37. So this will be 1.92 volt. So now E cell is equals to E0 cell minus 0.0592. Now here the two electrons are involved because Mg is also 2 plus and Fe is also 2 plus. So 2 log of concentration of Mg2 plus upon concentration of Fe3 plus. So this is 1.92 is equals to 1.92 minus 0.0592 upon 2 log of x upon 0.01. So in short, log of x upon 0.01 is equals to 0. So x will be equals to x upon 0.01 is equals to 1. Therefore x is equals to 0.01. So our answer is option E. Cylinder of is gas is assumed to contain 11.2 kg of butane. If normal family needs 20,000 kilojoule of energy per day, the cylinder will last for how many days? Given that the delta H of combustion for the butane is 2658. If I calculate for butane, that is C4H10, there are 12 carbon into 4 plus 1 into 10, that will be around 58. Now if I talk about 11.2 kg, how much heat of combustion will be done? So we know that 58 grams of butane, that gives out the energy of minus 2658 kilojoule. So 11.2 kg will be corresponding to, so it's 2658 multiplied by 11.2 divided by 58, but 58 is a gram, so I'm multiplying this by 1000. So that will comes out to be around 513269. So one cylinder contains this much energy. Now a family consumes 20,000 kilojoule of energy in one day. So it will consume 513269 in how much days? So 513269 divided by 20,000. So that comes out to be 26 days. Option C. Delta U of formation for the methane at certain temperature is minus 393 kilojoule. The value of delta H we need to find. Now heat of formation of the methane is C plus H2 giving CH4, balancing by multiplying this by twice. This is in gaseous state, this is solid state, and this is in gaseous state. So delta N, if we will calculate, product is 1 gaseous state minus reactant is 2, so this will be minus 1. We have a formula delta H is equals to delta U plus delta nRT, but this term is going to be negative, so obviously the delta H is less than delta U. So it is less than delta U, therefore our option is option C. Under same condition of initial concentration of 1.386 mole per dm cube of a substance become half in 40 seconds and 20 seconds through the first order and the second order equation, kinetic equations, ratio of K1 upon K0 of the rate constant we need to find. Now if I talk about if the K is a 1, that is first order, we have a formula 0.0692 upon T half. They have given 0.0692 upon its 40 second for the first order, and K0 is nothing but the concentration of initial concentration, which is 1.386 divided by 2 T half, so 2 into 20, so it is 1.386 upon 40. So if I need to find K1 upon K0, 40 will get cancelled, we'll get 0.0692 upon 1.386. This is almost double, so it is 1 by 2, so 0.5 mole per dm cube. For the reaction taking place in 3 steps, the rate constants are K1, K2 and K3. The overall rate of reaction is given as K is equals to K1 into K2 into K3 divided by K3. If the energy of activation values for the first, second and the third stages are given 40, 50 and 60, then overall energy of activation you need to find. First of all, we have a formula that according to the Arrhenius equation, K is equals to A e raised to E upon RT. If I put this in this equation, then A e raised to minus E upon RT will be equals to, I am writing for the K1, so it's A into E raised to minus E1 upon RT into A into E minus E2 upon RT divided by A into A minus E3 upon RT. Here A will get cancelled, so we'll have only E equation. So if I remove that exponents, I'll get E upon RT will be equals to minus E1 minus E2. This will become plus E3 upon RT. So removing that, we'll get finally E is equals to E1 plus E2 minus E3. So therefore, this will be equals to E1 is given 40, E2 is given 50 minus 60. So 90 minus 60, it's 30 kilojoule per mole. Oxidation states of metal in the minerals hematite and magnetite are respectively. Hematite is Fe2O3. So if I assume for the Fe, it's 2x, x for the Fe, then there are twice Fe, so 2x plus oxygen is minus 2 into 3 minus 6, that's equals to 0. So 2x is equals to 6, so x is equals to plus 3. Okay, and if I talk about magnetite, it's Fe3O4. So 3x minus 8 is equals to 0. So 3x is equals to plus 8. Now we can see this answer is going to come as a fractional. That indicates in this Fe is present in plus 2 as well as plus 3 state. So our answer should be 3 in hematite and 2 and 3 in magnetite. So option D. From the Ellingham's graph on the carbon, which of the following statement is false? CO2 is more stable than CO at 393 Kelvin. If I talk about, it's absolutely right. If you remember the graph of CO2 and the CO2 graph is generally horizontal, which is parallel. Generally the Ellingham's diagram is the graph of the delta G versus the temperature. This is generally horizontal, indicating its formation is independent of temperature, while the carbon graph is always decreasing. So if I talk about at 390, this temperature, if you'll find, this is around 1000 Kelvin only. In less than this, as I said, this is of carbon monoxide and this is of carbon dioxide. So this is around 1000 Kelvin, they intersect. Now less than 983 Kelvin, if you'll see, the delta G value of CO2 is negative. Whichever is having negative delta G, definitely it's considered as more stable. So option A is absolutely right. CO reduces Fe2O3 to Fe at less than 983 Kelvin. This is absolutely right, because CO, as the temperature increases, the CO becomes, delta G value is becoming more stable. So as you increase the temperature, definitely carbon monoxide can be used as a reducing agent at the lower temperature. So this will reduce the Fe2O3 to Fe. CO is less stable than the CO2 at more than 383 Kelvin. CO is more stable, we can see, because its delta G value is negative. So definitely option C is the false statement. The correct order of the acidic strength we have to decide. Now if we talk about the acidic strength, it goes on increasing as we go from left to right in the periodic table, because the non-metallic character increases. So if I find out the carbon belongs to group 14, nitrogen belongs to group 15 and sulfur belongs to group 16. So here the acidic strength should go on increasing, which is given wrong. Here if I talk about for the metals, potassium, calcium and magnesium. Now if I talk about potassium, it belongs to the alkali metal. Then calcium and magnesium belongs to the alkaline earth metal. The order should be exactly opposite. As we go from group 1 to 2, the acidic nature should go on increasing. Here chlorine belongs to the 17th group, sulfur 16 and phosphorus 15. So obviously we are expecting chlorine should have more acidic, then sulfur and then phosphorus. Therefore option C is the correct order for the acidic strength. The type of hybridization in chlorate ion and perchlorate ion we need to find out. Need to find hybridization, then we need to find the number of hybrid orbitals. In case of number of hybrid orbitals, when you need to find, we have a formula, that is half into the number of valence electrons of that atom, definitely valence electron for the central atom, then we add number of monovalent atoms which are attached to that central atom. Then we just add the charge on anion if that species given is the anionic species, and then we subtract the charge on the cation. So in case of chloride ion ClO3 minus, first of all, number of hybrid orbital, we have a central atom here, chlorine. So chlorine, number of valence electrons are 7. The monovalent atom we don't have anything, so plus 0, plus charge on the anion it's minus 1, so we'll add 1. It's not a cation, so minus 0. So 7 plus 1, 8. 8 divided by 2, it's 4. So 4 means we are expecting sp3 hybridization. Similarly, ClO4 minus, the same calculation will come, half 7 plus 0 plus 1 minus 0, that will be 4. So again this is sp3. So our option is option B.
So hi students, how's it going? Are the quality of questions good? Is it solving your queries and doubts? If you think you need more, you can of course write to us down in the comment section. Do subscribe the channel, like the video. If you have more doubts, write to us. Of course, it's chemistry, which means equations and numericals, and all of these will be there. They're all entangled and they're all together. But I hope you are pausing the video in the right way, studying for 20 minutes and then taking the right break, going through this in the right manner and revising and solving. So I really want to wish you luck. So I thought it's the right time to come in when ma'am was doing chemistry, and I thought I'll just come in. It's one of my favorite subjects. So, well, over to ma'am.
Which of the following arrangement does not represent the correct order of the property stated against it? So if you talk about option A, if we talk about vanadium plus 2, that means configuration will be 3d3, so it's having 3 unpaired electrons. Then chromium plus 2, that will be 3d4, so it is having 4 unpaired electrons. Then Mn, it is plus 2, so 3d5, 5 unpaired electron. Definitely we can see still a number of unpaired electrons are increasing, so paramagnetic behavior expecting to increase. Finally let's check for the Fe2 plus, it's 3d6, but here 4 unpaired electrons are there. So here paramagnetic nature is not increasing regularly, so our option A is not correct. In context of lanthanoids, which of the following statement is not correct? Because of the similar properties, the separation of lanthanoids is not easy. Definitely that's correct answer. Availability of 4f electrons result in the formation of compounds in the plus 4 state for all the members of series, which is absolutely wrong. We can see the option D over here. All the members exhibit the plus 3 oxidation state. That's the actual statement for the lanthanoids. The most common oxidation state for the lanthanoids is plus 3. So we are expecting the option is B, which is not correct. Which of the following complex species is not expected to have the optical isomerism? Optical isomerism will be exhibited by obviously CO-En thrice, because when we talk about En, it will be like this, and we can have a mirror image of this. We are expecting, if we talk about COEN, when we have the transform of this, it is not having the optical isomerism, but when we have a cis form of this, obviously we are expecting that will contain the optical isomer. So with this formula, optical isomerism is possible. Okay, now option C, with this compound we have only geometrical isomer. No optical isomerism is possible. This is facial one, and if we'll draw like this, there will be meridional. So definitely this is option C, which will not expected to exhibit the optical isomerism. The octahedral complex is metal ion M plus 3 with the 4 monovalent ligand L1, L2, L3, L4 absorbs wavelength in the region red, green, yellow, blue respectively. The increasing order of ligand strength we need to find. When we talk about the energy wise, the energy is expected to increase from red color to yellow color to green color and to blue color. So definitely if we talk about with the blue, the strength is also very high. So who is having blue color over here? L4. So L4 will be having highest energy content. Then green. Green is with L2. Then yellow, that is with L3. And finally the red. Red is with the L1. So order is L4 higher than L2, L3, L1. So option is B. When 3-phenyl propene, so if we draw the structure C6H5 CH2 CH double bond CH2 plus HBr is added in presence of peroxide. Peroxide gives the anti-Markovnikov's rule, where the negative part of the reagent goes to the carbon atom having more number of hydrogen atom. So we'll get C6H5 CH2 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 Br. So we are expecting, if we number this particular compound, so it's around 1 bromo, 1 2 3 3 bromide, that is a phenol, that is 1 bromo phenyl propane. So option is D. Amongst the following, the one that gives the positive iodoform test. Positive iodoform test will be given by those alcohols or aldehydes or ketone having the CH3 group immediate in the vicinity of the functional group. If we'll talk about this particular carbon which is bearing the OH is not having CH3 in the immediate vicinity, so this won't give you the test. If we talk about, again, we have this carbon bearing the functional group is not having CH3 in the close vicinity. This is the carbon having the OH having CH3 in the close vicinity. So option C will give us the iodoform test. If we'll talk about the oxidation of this cyclohexanol with the chromic acid, we'll get the cyclohexanol, which is on treatment with the Grignard reagent will take place over here. CH3 will be given to carbon OMgBr, followed by the hydrolysis will give you the product. This will become CH3 and then OH. So our option is option D. Organic compound with the molecular formula C7H8O. If we talk about, this is the aromatic compound will be almost having C6H5 ring. So C7H8O minus C6H5. So if I'll do this, I have one more carbon left, 3 hydrogen and O. So if I talk about, it is something a phenolic compound we are expecting which dissolves in NaOH. So it's a confirmatory test and characteristic color with the FeCl3. So definitely this is a phenol having CH3. But we don't know exactly the location of CH3 over here. But on treatment with the Br2, it gives tribromo products. If we allow the OH to react with the bromine, it gives the reaction at 2, 4 and 6 position. But after having CH3 also, we are having all 3 position reaction. That means the CH3 has to be at meta position. So our compound has to be CH3 attached to OH. So it has to be meta hydroxy or metacresol simply. So option C. The ketone reacted with C2H5Br. So let's say there is some ketone which is reacting with the C2H5MgBr. We don't know about R1 and R2, let's say. So if ketone reacts with MgBr followed by the hydrolysis, we are expecting the product alcohol. So we'll expect R1, this carbon will be attached to the C2H5 group. This will be R2 and this will be OH. This particular compound on dehydration is giving us the formation of alkene. So this dehydration will give us the formation of alkene. This alkene on ozonolysis, when we do the ozonolysis of this alkene, we are getting 2 different products. That is, one product is acetaldehyde, that is CH3CH double bond O, and one product is diethyl ketone, so C2H5C C2H5 double bond O. So simply we can obtain this alkene by removing this O. So we can write C CH3 C double bond C C2H5 C2H5. I'm just removing the double bond O to get the alkene, because ozonolysis breaks the molecule to give the two different aldehyde ketone like this. So this is the alkene which is obtained. Now if you'll see, this particular alkene is being obtained by the dehydration. So dehydration, if I put the H and OH over here, so we'll get that particular alcohol, and from alcohol we are expecting that ketone. Now if you talk about this particular ketone, definitely this one C2H5 group is coming from the Grignard reagent. So other C2H5 is with the keto compound, and one CH3 is with that ketone, because one C2H5 group is coming from the Grignard reagent. So definitely we are expecting a ethyl methyl type of ketone. But definitely we are getting this by the dehydration. We don't have to forget there is one extra carbon over here, so there has to be C2H5 on both sides. That only will give you the product. So this is C2H5. It's again, I'm repeating, one C2H5 is coming from the Grignard reagent. One C2H5 has to be there as a group. This is a carbon which is, let's say, bearing a carbonyl group. So apart from that we have two groups. So there should be C2H5 also. So it should be diethyl ketone. So option B. The product of the following reaction, if you'll allow this to react with I2NaOH, I2NaOH will give us the formation of the iodoform CHI3, along with this particular compound will turn to corresponding acid. And this acid, if you heat it, because they have told us to heat also, heat it, simply will turn to cyclohexanol. So option B. On heating aliphatic amine with the chloroform and ethanolic KOH, so aliphatic amine is there, simply aliphatic amine, so RCH2NH2, which is on heating with chloroform CHCl3 and ethanolic KOH, so alcoholic KOH. This is the isocyanide test, which gives the corresponding isocyanide with the foul odor. So option is option D, alkyl isocyanide. Considering the basic strength of the amine in the solution, having which of the following will have the lowest smallest pKb? This is secondary amine, this is primary amine, this is tertiary, this is primary again but aromatic. Amongst all, the secondary amine is the most basic. The one which is most basic is having the lowest pKb value. So our option is option A. Which of the following is not a correct match for the polymer and its monomer? Buna S indicates butadiene and styrene. Butadiene and styrene. Gliptin, it's ethylene glycol and phthalic acid. So they are also right. Nylon 6 hexamethylene diamine and 6 adipic acid. Bakelite, formaldehyde, and instead of this there should be phenol. So this is not the correct option for this.
I hope that must have helped. That was quite a lot, right? So, well, I'm here to tell you good luck for this particular paper of chemistry, and I hope you really learnt well. And if you want more, you can visit meritstore.in, and in the description you can see we have provided you with a free course. You can just take the free course and learn whatever you want to learn from that.